So
Okay.
today we are doing paper 4 from the IGCSE 0620 Specimen. This is the theory paper for the extended syllabus. Now, the last class we had, which wasn't recorded because I had internet issues, we did actually attempt these questions to begin with. And so what I'll do is you can obviously see this on the board.
Mm-hmm.
Yeah. Okay, I have the tab working again. And what color would we like to use? Green, maybe? Just for
Yeah.
fun.
Yeah.
Okay, so name each of the numbered. So one, a solid going from solid to liquid. So that's melting.
Wasn't I supposed to answer?
Well, you already did the last time.
Oh yeah.
If you want to go again, sure. Right? So what's two?
Liquid to solid is freezing.
It's gas to liquid. Two.
Oh, gas to liquid. Condensation.
Yes. Three.
Freezing.
Yes. And
And the
four.
boiling or evaporation.
Right, so either can work and explain the last time just because they're focusing on the change of state and not the conditions that which are causing that change of state. Either of these can work. Right, on the safe side, you would go for boiling, but evaporation also works. Okay, then, right, one difference between boiling and evaporation is the rate at which the process occurs. One other difference, right, so Sobia, since you're the only one here at the moment.
If I'm not wrong, the last time I answered this was um, evaporation is only at the surface,
Yeah.
while boiling is at the boiling is affects the whole thing.
And so evaporation occurs at the surface, right? Boiling happens throughout the liquid. And there is a, I just realized if I'm doing it this way, I'll have to answer the entire paper in writing for you guys. You are just going to be giving me like verbal responses, and I'm the one who'll have to actually write it out. Alaikum assalam. How are you, beta? So that is right. The response you would give. There's another one about the temperature, right? So boiling has a fixed temperature, whereas evaporation can occur over a range. That's another point you could have written down. Okay, so we only got this far. Now describe the separation, arrangement, and motion of particles of element X in the solid state.
What is meant by separation in it?
So separation means how far apart are
May I?
they? Hmm?
Can I answer?
Yeah, yeah.
Okay, they're closely packed together, and they vibrate in fixed positions and waves,
So
and
motion,
they are in regular pattern.
motion is vibrating in fixed position, right? Separation is closely.
Closely packed together.
Okay, now the suggested answer is actually touching, right? But again, in these cases, it's up to the examiner whether they award you a mark or not, right? I feel that you should be awarded a mark for this, right? And the arrangement, what did you say for arrangement?
They are in regular pattern.
Regular. Right, so regular is what they're saying as well. Okay, and finally for question 1, element X is a group 3 metal. It burns in air to form an oxide X2O3. Write a symbol for this reaction. Sorry, symbol equation. So we have X, right? That's the metal, and that's a solid, and it's burning in air. So basically, that's oxygen. And what do we write for oxygen? O, just O,
O2?
O2, because obviously it's a diatomic gas, and you write G over there, and you get X2O3. Right, now we need to balance this guy.
Yeah, you gotta put a 2 on the X,
Mm,
if I'm not wrong. Or am I?
well, that wouldn't work. If you put a 2 on the X, what about the O3? You've got O2 over here, you've got O3 over here. I mean, one thing you could do, right, which is not something
Uh,
I'd suggest you doing, is this.
so then we can write 3 on like the reactant side and 2 on the product side.
3 on the reactant side for
Yeah,
oxygen.
yeah. For oxygen and like the element X,
All right, so
element X as well.
three oxygens over here. So that would give us 6 oxygens, which works, but that's giving us 4 of element X. And so in that case,
Right. Cool.
yes. All right, so what I did earlier, this is correct, but this is not what you want to do in an exam, because they want nice whole numbers, right? So if you're getting something like this, just to even this out, you can just multiply the whole thing by 2, and so you're going to get this equation, which is what they want. All right, but yeah, let's just not go into decimals and fractions. All right, so let's not do that. Okay, so done with question 1. Question 2. Magnesium, calcium, and strontium are group 2 elements. Okay. Complete table 2.1 to show the electronic configuration of the calcium atom. Right, now the good thing over here is that you have the periodic table.
Yeah.
So if you go down here and we take a look at calcium, and we know that it has 20 electrons. All right, so if you realize how electronic configurations work, this is easy to do. So how many electrons is the first shell going to have?
Mm. We are talking about calcium here, right?
Yes, calcium.
Can you show that again, like the periodic table?
It's 20. The atomic number is 20.
So 2,
So the first shell will have 2,
then 8.
8,
Yeah,
and
they have 90 electrons, huh?
yeah, 20 electrons.
Then 8 again.
So we're up to how many? 18 now. And so yeah,
2.
2. So yes.
Okay.
Okay, so describe how the electronic configuration of strontium, right? And you don't need to look at the periodic table over here because it mentions that strontium and calcium are in the same group. So explain how the electronic configuration of a strontium atom is similar to the electronic configuration of the calcium atom. So how are they similar? What's the similarity?
Um, like how many electrons are in the strontium atom?
Okay, let's take a look again at the periodic table. So strontium is down here.
They have two electrons in the outer shell.
That is the similarity, yes. So strontium is 38. All right, Haran?
They have 10 more electrons than magnesium, than calcium.
Okay, so first let's do the first part. And we're talking about similarities. So I'm new to the software, so I'm learning how to navigate it. So the similarity, as Sobia said, would be right same number of outer or valence electrons. And what's the difference?
They have 18 more electrons.
Okay, so you could say, right, but it's talking about the configuration, so just not right. What's different about the configuration? So if it has 18 more electrons, what can you say about the configuration of the strontium atom?
It is
Then they
larger atom.
have,
Huh?
It is a larger atom.
Well, yes, but that's not configuration.
then there are like more shells than
Exactly.
calcium.
Yes. So strontium has more electron shells. Right, so the wording is important. I mean, you could just say that it has more electrons, but saying that it's more electrons does not tell you about the configuration of the atom, right? So the wording of the question is important to focus on, definitely. Okay.
Yeah.
All right. Now, part C, calcium reacts with cold water to form two products: a colorless gas which pops with a lighted splint, and a weak alkaline solution Q which turns milky when carbon dioxide is bubbled through. Right? So, what's the gas?
Calcium hydroxide,
The gas, the gas that which pops.
carbon dioxide,
Huh?
carbon dioxide,
Carbon dioxide will put out a burning flame.
Hydrogen.
Hydrogen. Right? So the test for carbon dioxide is you pass it through lime water and it turns it milky or cloudy. Another test, which is sort of not like it, the reason why they don't say it is because it's not a specific test. That if you take a burning splint and you put in carbon dioxide, it will extinguish. So, but again, right, other gases can also possibly do that. So it's not a specific test, but you can get an idea about it. Okay, so it's a weakly Q is a weakly alkaline solution. Identify the ion responsible for making the solution alkaline. Again, wording. Identify the ion responsible for making it alkaline. Which ion?
what
I
Hydroxide ion.
The hydroxide ion. Right. So you can either write hydroxide,
Or just write the ion is the hydroxide ion.
yes, or you could write OH minus.
Hmm.
Right. Either works. Okay, suggest the pH of a solution, right? So it's weak.
7, no, 14.
Hmm?
What is it?
So what did you say, Haran?
14 or, yeah.
14 for 14 is very
14 is the
alkaline.
strongest alkaline on the scale.
Well,
Those are
it can
8.
actually go up to 15, but that's a different story. So yes, 14 is strong. So you don't want, like, it's weakly alkaline. So what would you say?
8.
8. Let's say 8. It
I get
suggests
confused with
now,
8.
right? So 7 is neutral, and so you don't
So
want.
anything after 7 could be a
Yes.
correct
So
answer, right?
anything between 7 to, let's say, 11 or 12, right?
Okay.
Now you want it to be as close to 7 as possible. You could select 7.5, right? That is weakly alkaline. 8 is a nice, it's a nice whole number. It works, so that's better. And again, the question is asking you to suggest. So they're not asking you to, like, no, give us the exact value, right? So suggest is basically making an educated guess, right?
Okay.
Okay, write a symbol equation for the reaction of calcium with cold water, right? So
8
you've got calcium,
plus H2.
H2O. By the way, this is a solid and this is a liquid. And so you are getting hydrogen gas. So let's write that first. And then what is the weakly alkaline solution that you're getting?
CaO. Calcium oxide.
Calcium oxide is, if it's calcium oxide, then where is the OH going?
Oh, yeah. Um,
Right.
calcium OH.
Right. One
13
thing you want to, like, I'm sorry, I'm cutting you off, but one thing you want to keep track of is the sequence of the questions, right? They're building it up. So if you mentioned, like, they're saying it's alkaline, it's a solution, right? So calcium oxide is not a solution, first of all, right? And you identified the hydroxide ion. So you want to keep track of your own answers and what the questions do. So they're building it up for you, right? Instead of just giving you like a 5-mark question, like, oh, tell us all of this information in one go, right? So it's obviously, right, the alkaline solution you're getting is has calcium because metals make alkaline solutions, and it has the hydroxide. So what will it be? Ca.
OH2.
Good. OH, right, in brackets and twice. Now we need to balance this. What do we need to do to balance
We have to put a 2 on the reactant side
it? Where?
for H2O.
Yes. And that would, right? So always when they're asking you for equation, right, you need to give a balanced equation.
Obviously, yeah.
Okay.
Yeah.
If you don't give a balanced equation, you'll only get 1 mark, and that too depending on whether at least you've given the
Correct.
formulae for the reactants and products correctly. If the formulae are wrong, then you get nothing.
And the marks go down the drain.
Well, you don't get negative, like, you don't have negative marking. You just don't get the mark.
Yeah.
Okay, magnesium reacts with chlorine to form magnesium chloride.
Oh
Magnesium
my God.
chloride is an ionic compound. Complete the dot and cross diagram of the ions in magnesium chloride. Show the charges on the ions. So what is, like, it's just 2 marks. Okay,
Could
so
you like zoom out with the question?
I could.
Yeah, that's okay. Yeah.
how many electrons are in magnesium and chlorine?
Uh-huh.
How many electrons are there in magnesium and chlorine?
So chlorine, wait, let me just go to the periodic table. Okay, here we have the periodic table, and so chlorine has 17 electrons, and so that's 287, so 7 outermost electrons, and magnesium is 12, so that's 282, right? So 282 and 287. Now, going back to the question,
We're gonna give the um, two classes of magnesium to chlorine ions.
no, because you see that the chlorine ions already have full outer shells. So that's already
That's good.
happened. What they're asking you to do, that's too much. Okay, that's fine, I guess. So what they're asking you to do is complete the dot and cross diagram of the ions. So, right, the chlorine are, they have 8 outermost electrons, so they're happy, right? So magnesium only has 2, so I guess, right, one thing that you have to do is show 8. So magnesium was what? 282, right? These have been given to chlorine, so you need to show 2, so you need to show 8 electrons. So you want to make more electrons, so that's one. So that's 1 mark, right, out of 3. And then show the charges on the ion. So this is +2, this is -1, and -1 individually. Yeah.
Okay. Yeah, got that.
2872. Oh, my bad. Sorry. Uh, right, sorry. So this is just 28. My bad. Okay. So
So was I correct?
yeah, you need to make the outer shell, and you need to show.
Can't we just put the crosses instead?
Oh, it's only going to have one cross, right?
Yeah,
So there, and similarly for this.
cross on each fluorine.
Huh?
One cross on the top chlorine and one cross on
Yeah,
the
and so
low.
you don't have to worry about having a perfect circle. Oops, not crosses, dots.
Does it matter where you put the cross?
No, as
Okay.
as long as you clearly show that there is a cross.
Okay.
Okay.
Yeah.
So yeah, so that gives you 3 marks. Okay, one physical property typical of ionic compounds such as magnesium chloride is that they are very soluble in water. Give 2 other properties that are typical to ionic compounds.
They have high melting and boiling points.
So you can mention only one of those.
Okay. Or they can conduct electricity when molten.
Okay. Conduct. A good thing about these papers is that you don't have to be grammatically correct as long as you're giving the correct answer.
Oh, yeah, it's not an English exam.
Huh?
I mean, it's not an English exam, so yeah.
Exactly. So conduct electricity when molten or when aqueous, so either of those.
Okay.
Right? Now, one thing I guess we should add is instead of just saying conducts, I'm correcting myself. Good conductors. of electricity. Saying that would be better.
And they also have a high boiling,
Could you repeat that?
and they also have a high boiling point.
Yeah, so high melting point. The thing is, in the mark scheme, if right, they're going to award you 1 mark whether you mention high melting point or high boiling point. So if you're going to treat those as two separate properties, that's not going to work. You still only get 1 mark,
Okay.
right? So they want two separate properties. It's kind of this, the reason for that is perhaps it's kind of the same category of property. High melting point, high boiling point. It's the same category. So that's why. Okay. Now, aqueous silver nitrate is added to aqueous magnesium chloride, right? A white precipitate forms. Write an ionic equation for this reaction and include state symbols. Right, so first of all, we need to identify what that white precipitate is. So you've got silver nitrate, so AgNO3 plus MgCl2 will give you MgNO3 plus AgCl2. Alright, so which one's the white precipitate over here?
Could you repeat the question?
In fact, let me correct that. So silver's oxidation number here is 1. Right, so that is the chemical equation for what's happening. Aqueous silver nitrate being added to aqueous magnesium chloride. Right? So these guys are aqueous, both of them. This guy will still be aqueous. And right, there's a white precipitate. Now, I've written out the chemical equation for you guys, right? Just I'm solving the paper with you. So
Yeah,
what over here is the white precipitate?
the white.
The question says a white precipitate forms.
Yeah,
What's the white precipitate over here?
IGCL.
AgCl, right? So that's if it's a precipitate,
the
it's a
silver chloride.
huh? Silver chloride is the white precipitate,
Yeah,
right? And that's a solid. Now, this is not the answer because they want an ionic equation. So, given what we have on screen, what's the ionic equation?
Ag plus uh Ag with the plus ion and plus Cl minus, which gives us AgCl, if I'm not wrong.
That is correct. What about the state symbols?
The way?
State symbols.
Oh, Ag is aqueous and Cl is also aqueous, and the product which gives us is solid.
Good. And so you get your 2 marks. All right. Having fun?
Yeah, not bad.
Question 3. Copper is a transition element. It has variable oxidation states. We know that it has 1 and 2. State 2 other chemical properties of transition elements which make them different from group 1 element.
Their reactivity in no, their reactivity increases down the graph.
Yeah, that doesn't apply to transition metals.
Okay.
Uh, they form colored compounds.
Good. And another?
Uh, we can't say we can't. List physical properties, right?
It's not given the mark scheme, but what are you going to suggest?
Like if it was physical properties, like it would be like high density or high melting point. But would that fit the answer here?
Wait. So it says chemical properties. Now the question is clearly saying that.
Okay.
Again,
So
reading the question is very important.
yeah.
It says chemical properties. So one is right. They form colored compounds.
They act as catalysts.
Yes. Okay. When copper 2 oxide is heated at 800 degrees centigrade, it undergoes the reaction shown by this equation, right? Copper 2 oxide breaks up into copper 1 oxide and oxygen, right? So that happens. Identify the changes in oxidation number of copper and oxygen in this reaction. Explain in terms in oxidation numbers why this is a redox reaction. So the change in oxidation number of copper is going from what to what?
From 2 to 1, or from 2 to 1,
Plus 2 or minus 2?
plus 2.
Right. So plus 2 to plus 1. What about oxygen?
From
Plus 2
minus
to
2 to
plus 2.
0.
Yes. So what you're going to focus on over here is this guy, right? Because you're having oxygen gas evolve at 800 degrees centigrade. Otherwise, you're going to say, oh, it stays the same, right? Because it's still reacting. And so, no, I mean, there is a change happening. Now, explain in terms of the increase or decrease in oxidation number, what's happening.
Uh, Haram, you can answer.
Because oxygen is being gained.
So, yeah, go ahead.
Because oxygen is gained,
It has it gained electrons?
it has like gained electrons.
It's not gaining electrons, it's going from minus 2 to 0. It's actually oxygen is being oxidized.
I was saying it is gaining oxygen.
It's not gaining oxygen, right? So recall, right, how we define oxidation reduction. Oxidation can be the loss of electrons.
This
Uh,
is a redox reaction
this is a redox reaction, right? So
because both oxidation and reduction are occurring
yes,
simultaneously.
but how, right? So oxidation is the loss of electrons, the loss of hydrogen, the gaining of oxygen, or an increase in oxidation number,
So the copper is being reduced, which
right?
means
And
that
we flip all of that. So a gaining of electrons, a gaining of hydrogen, a loss of oxygen, or a decrease in the oxidation number is reduction. So don't just focus on the plus and the minus, see whether the number is going up or going down, right? So for the copper, the number is going down. And so the oxidation number decreases, which is reduction,
yeah.
of
Okay.
copper decreases, which is reduction, and oxidation number of O2 increases, which is oxidation. Okay, now calculate the volume of oxygen measured at room temperature and pressure. which is formed when 1.60 grams of copper oxide, copper 2 oxide, reacts as shown in this equation. The first thing you need to establish is what is the mole ratio between copper 2 oxide and oxygen?
So 1.
4:1, right? Then what's the next step we need to do?
Find like the each gram.
Okay, well, what's the first thing we need to do to carry on with our calculation?
Find the moles.
So what would you do to find the moles?
Relative mass formula.
Right. So MR of
64 plus 16.
64 plus 16, which gives you 80.
80. Yes.
Right. And then number of moles,
Equals to mass. So divided by
1.60, right?
1.60 divided by 80.
Yes. And what is that giving you?
0.02 moles.
0.02 moles,
Yeah.
right? And so it's 4:1, right? So you
So,
divide this by 4. So
which gives us 0.
number of moles of O2
0.02.
equals to 0.02 divided by 4, which gives us,
0.005.
right? And then volume of O2 produced
Mm,
equals to 0.005 into what is the volume of 1 mole at RTP? Huh?
24 dm cube.
Yes.
So it
Right?
is 0.005 multiplied by 24,
Yes.
which gives us 0.12 dm cube.
0.12 pm cube. And so you write it over here 0.12. And that is your answer.
Okay.
Okay?
Yeah.
Good. All right.
Can we do this last question?
Huh?
Is this the last question for today?
Yes, it will be the last question for the day.
Okay.
Okay, copper metal is obtained when scrap iron is added to aqueous copper to sulfate. The reaction between iron and aqueous copper to sulfate is a displacement reaction. State why this displacement reaction takes place.
Mm. Yeah, Hiram, you can answer that. I have been answering, I think, the most, but yeah, you can answer.
Like,
Huh?
because copper is more reactive.
Copper is more reactive. Copper is being replaced by iron.
Iron is more reactive.
Sorry,
Iron is more reactive.
sorry.
Is more reactive than copper. Okay. Write a symbol equation for the reaction between iron and aqueous copper. So you've got Fe over here, and copper to sulfate would be what?
COSO4.
Cu, not Co. Co is cobalt.
Oh, sorry.
CuSO4, and that
Which
gives you,
FeSO4 plus Cu.
so you're making iron 2 sulfate, FeSO4 plus Cu, right? And this is balanced in itself,
Yep.
right? What are the state? What would be the state symbols?
What will be the void?
State symbols.
Solid.
So iron would be
Solid.
solid. Copper 2 sulfate would be,
Aqueous.
and then iron 2 sulfate would be,
And solid.
no,
Uh,
it's a displacement reaction. Okay. Finally, for today, a displacement reaction is one method for obtaining copper metals from aqueous copper to sulfate. Identify another method for obtaining copper metal from aqueous copper to sulfate. This is the one that you learned in your syllabus. Which one is it?
Electrolysis.
Yep.
Analysis.
All right, you guys did well.
Yeah.
You guys did a good job today. Okay, so we'll stop here. We'll continue with this next time, inshallah. We are
Acha.
done with like what, 3 questions? Which page is this? Page 6. How many pages? 16 pages, right?
Well, damn.
So yeah, we do have. Oh,
Quite a lot.
there's a blank page in between for no reason. So the next
Yeah.
question is titration. So that's going to be fun.
Yeah.
Okay, we can possibly complete this in the next class. Possibly.
I mean, there is a chance of 2 or 3 questions maybe left.
Uh, let's. I mean, we will see when time comes. Obviously,
Yeah.
we want to
Okay.
be as productive as possible. But yeah, we are done for the day. So, right, go take a nap, something. Right.
Yeah. Okay.
See you guys next
Allah
time,
Hafiz.
inshallah. Allah
Allah.
Hafiz.
Enough.
Allah Hafiz.